Okay, boys and girls, it's time for us to put it all together. Today we're going to be looking at equal algebraic expressions. Okay, we're going to take a look at algebraic expressions that are the same, but they look different. Okay? We can do that now. Let's take a look at some sample problems together.
Boys and girls, let's get out our equivalent algebraic expressions handout. And let's take a look at number 3, and we can do this one together. It says that we're supposed to evaluate these expressions to see if they are equivalent, and if they are, underline the property that makes them true or equal. Well, here we have 2z times 3 times 2 is equal to 2 times 3 times 2z. Now, at a quick glance, I can see that both expressions have the same terms of 2z, 3, and 2. As far as operators go, the only operation that's taking place is multiplication. So we have the same terms, the same operators. The only thing that's different is the order of the terms. So this sounds like this is exhibiting the commutative property of multiplication. And both of these expressions should be equal. They should have the same value. But let's go prove it. Let's work through this. Let's follow order of operations. Order of operations simply states, since both operators are the same, we just work left to right. So 2z times 3 is 6z. Bring down the rest of the information, which times 2. Okay. So if I have 6 z's and then I double it all together, I would have 12z. Okay. Over here, we just go left to right, same thing. 2 times 3 is 6. Bring down my 2z. And then 6 times 2z would give me 12 z's all together, and sure enough, 12z is equal to 12z. So this is true, and this exhibits the commutative property. All we're doing is moving around or changing the order of the terms. Boys and girls, let's slide down to number 7 and take a look at this sample problem as well. I see that I have 3 times the sum of 5x and 2 is equal to the product of 3 and 5x plus the product of 3 and 2. Well, the first thing I'm doing is going to practice my distributive property here, and if I need to distribute this first term 3 to both of the terms inside the parentheses multiplicatively, so 3 times 5x would be 15x. Okay, just imagine having 5 x's 3 times. We add them all up, we'd have 15 x's. And then 3 times 2 is 6. Okay, and if we go over here and just perform our multiplication, 3 times 5x is 15x. And then 3 times 2 is 6. So that was very simple, and sure enough, 15x plus 6 is equal to 15x plus 6. So both of these expressions are equivalent. Let's take a look at this graphically. Now I know that my my drawings might not be to scale, but they're pretty close. Just play along with me. Let's say we have a box here that is, draw a line in here. Okay, let me get out of this mode. That is 3 units high, and then it is 5x long plus 2. We're not quite sure what x is, but we'll just say it is. And then over here we have 2 different boxes, or 2 different rectangles, I should say. The first rectangle is a 3 by 5x rectangle. And then this rectangle over here is a 3 by 2 rectangle. I think you can see where I'm going. The area of this section of this rectangle is going to be 3 times 5x, or 3 by 5x, which is going to be 15x. And then the dimensions of this section of the rectangle is 3 by 2, which will be 6. Over here, so we have the area of 15x plus 6 units. Over here, we have two rectangles. We have a 3 by 5 rectangle, or 5x, which will be 15x. And then this rectangle over here is a 3 by 2 rectangle, which will also be 6. So graphically here we can represent it as a rectangle that's divided into two lengths, and over here we just have two rectangles that both have the same height, but their length combined is the same as this rectangle over here. So we can see that they're going to have the same area. Let's do one more sample problem together on our practice handout. Go to number 11, and the problem states, the path through the forest at high elevations is made of gravel that is 4 feet wide by 3 feet deep for every foot long. Okay, while the path through the low swampy regions is 3 feet wide by 4 feet deep for every foot long. Okay, that makes sense. In the swampy, wet areas, you're going to need more drainage, so you want your road to be a little deeper, have deeper drainage. Okay, so what are we supposed to do with that? It says, write an expression for each path and explain which uses more cubic feet of gravel per foot. Well, that's simple enough. They're giving us the dimensions of each path. So I know that the path at the high elevation has the dimensions of 4 feet by 3 feet for every 1 foot. Okay, which would give us the cubic footage of 12 feet, 12 cubic feet. And then at the low elevation, in the swampy regions, it says that the dimensions is 3 feet wide by 4 feet deep for every foot long. And sure enough, when I multiply this, I will also get 12 cubic feet as well. So 12 cubic feet of gravel for every foot of path. So what I see here is we're just taking 4 times 3 times 1, and that's equivalent to 3 times 4 times 1. Once again, we have the same three terms, 4, 3, and 1, 3, 4, and 1. They're the same terms. We have the same operators of multiplication. The only thing we're doing is moving or commuting these numbers around. So what we just exercised here was the commutative property. I think you guys are getting it.
Okay, boys and girls, you should be pros by now and put it all together. Now we can take a look at expressions that may look different, but they're equivalent. Okay, we can now find two equivalent algebraic expressions and prove that they're the same thing, that they have the same value. You guys are awesome. I'll see you later.